This is for Year 12 methods. It's Tech Task 2, finding domains and ranges of questions 10, 11 and 12. In question 10, I've got this here, and this is a hyperbola, but it's not in the right form. If I do a quick little division, I've got 2x minus 5. X goes into 2x twice. 2 times x is 2x. 2 times that's minus 6. I get 1 as my remainder, so that's the same as having 1 over x minus 3 plus 2, which means that my domain can't equal 0, so therefore x is everything except 3, and I have an asymptote at 2, so the range is everything except for 2, because it becomes a hyperbola. This thing here is a circle. My general rule for the circle would be y equals the square root of r squared minus x squared. If I square both sides, y squared equals r squared minus x squared, and x squared plus y squared equals r squared. So it ends up being a circle. However, I've only got the positive square root, and my r squared would be 5, so my radius is root 5, I'm sorry, and I have the positive square root, so I'm going to go from negative root 5 to root 5 up to root 5. So negative root 5 to root 5 inclusive, because my circles can be there, and the range goes from 0 to root 5, so therefore that's value there. If I was to use the logic as to what can't be underneath the square root, then I've got 5 minus x squared has to be bigger than or equal to 0 to be able to take the square root of it. Here I have a parabola which goes through at 5 and is upside down. It will have x-intercepts at root 5 and negative root 5. Where is that parabola bigger than or equal to 0? Well, it's bigger than and equal to 0 here. So the values of x I want are between negative root 5 and root 5, which is what I've got there. And the third example is a logarithm graph. Because of the negative on the x, it shoots that way. This has to be bigger than 0, so 5 minus x has to be bigger than 0, minus x has to be bigger than negative 5, which means that x has to be less than 5. So it's over here at x equals 5, and it has this shape to it. So its domain is negative infinity all the way up to 5, but not inclusive, and the range is all real numbers. Done.